All right, welcome. Today we've got an absolutely incredible story for you. It starts with something you can look up right now, a peer-reviewed paper in the journal Nature. But where it ends? Well, it ends with the very real, very tangible potential to engineer space-time itself. Seriously, we're going to go from a proven quantum experiment all the way to the future of the cosmos.
Just listen to that. I was shaken. Those are the words of Dr. Maria Spyropoulou, the lead researcher over at Caltech, the moment she saw the signal that proved it worked. It just gives you chills, right? It's such a powerful reminder that behind all this mind-bending science, there are real people having these moments of, absolutely profound, earth-shattering realization.
And this is what made her say that. Now, let's be crystal clear about something right up front. This is not science fiction. This is real. In December 2022, a team, we're talking Google, Stanford, Princeton, published a paper in Nature. And in it, they detailed how they successfully sent quantum information through a traversable wormhole, one they created inside their Sycamore quantum processor. So that's our starting point. Not a theory, not a wild idea, but a verified, published scientific fact.
Okay, so let's really get into this breakthrough. To understand how in the world they built a wormhole, we actually have to back up a little bit. We got to look at another crucial invention they made just a year before. You see, this whole story, it doesn't start with speculation. It starts with a real landmark experiment.
So check this out. A full year before the wormhole experiment, back in November 2021, that very same Google team created the world's first ever time crystal. Then they used that exact same technology to stabilize their quantum computer, which is what let them pull off the wormhole in 2022. Now, this sequence of events is absolutely critical. This was not a coincidence. One breakthrough was literally the key that unlocked the next.
So you might be asking, why? Why was the time crystal so necessary? Well, because creating a stable wormhole, even a tiny one at the quantum level, is just unbelievably difficult. The whole system is incredibly fragile. The time crystal did a few crucial things. It provided perfect quantum coherence. It stabilized the really exotic negative energy needed to prop the wormhole open. You can think of that as a force that pushes space-time apart instead of pulling it together. It perfectly matched the wormhole's own periodic structure, and it shielded the superdelicate signal from all the background noise. I mean, without the time crystal, the whole experiment would have just failed. Period.
Okay, so that brings us to the time crystal itself, the secret ingredient. What in the world is this new phase of matter that made all this possible? I know, it sounds like something straight out of a comic book, right? But believe me, it is a very, very real and very bizarre phenomenon.
Okay, so a time crystal, it's a whole new phase of matter. Like solid, liquid, gas. But here's the twist. Its atoms aren't just arranged in a repeating pattern in space, like a normal crystal. They're arranged in a repeating pattern in time. They just cycle, they oscillate between different states forever without needing any energy input. The best way to think about it, it's like a clock that runs for eternity, without ever needing batteries. Perpetual motion in a crystal.
So how do you know you've actually made one of these things? I mean, how do you prove it? Well, that's what's so cool. A time crystal has this unmistakable fingerprint, a unique signature called period doubling. It's pretty simple, actually. You nudge the system with a laser at a certain frequency, we'll just call it F, and a real-time crystal will respond by oscillating at exactly half that frequency, F/2, every single time.
And here you can see that signature in action, with the actual numbers from the experiments. The scientists drive the system at 7.83 Hertz, which, fun fact, is the Earth's natural Schumann resonance. And boom, the system responds clear as day at 3.915 Hertz. Exactly. Half. This F to F/2 relationship, that is the absolute gold standard. It's the smoking gun that confirms you've made a time crystal. So remember that relationship.
Okay, so this brings us to the big question, right? The absolute pivot point of this whole story. On one hand, we have this super stable quantum system, the time crystal. On the other, we have a tunnel through space-time, the wormhole. So, what is the real connection? What's the fundamental link between these two incredible, mind-blowing concepts?
And here, this is where we make the leap. This is the moment. This is where we connect that proven, peer-reviewed quantum experiment to a future that could literally redefine everything we think we know about travel, about physics, about everything. Okay, get ready for this, because this is the crucial insight, the big reveal. The time crystal isn't just propping the wormhole open, like some kind of external scaffold. No, the central discovery, the really breathtaking realization, is that the wormhole throat is a time crystal. Not like a time crystal. It is one. It's not an analogy. It is a literal one-to-one physical equivalence.
And the proof? It's right there in the physics. A wormhole throat, it checks every single box. It has all 6 defining characteristics of a time crystal. It oscillates in time, periodically. It shows that F to F over 2 period doubling we just talked about. It's stable even while it's full of that exotic negative energy. It doesn't lose any energy. It shows many body localization, which just means its particles are kind of locked in place so they don't heat up and destroy the system. And it breaks time translation symmetry, which is just a very fancy way of saying it creates a stable, repeating tunnel through time itself. It is, in every way that matters, a perfect match.
And this idea, this one-to-one identity, this is the bedrock for everything that follows. This is the bridge. It's what allows us to take the proven physics from Google's tiny quantum chip and start applying it to designs for macroscopic, human-scale technologies.
You know what's really validating about all this? It's that completely different fields of research are all arriving at the exact same answer, totally independently. You've got the proven quantum computing approach. But then, way over in another field, you have theoretical propulsion systems, like the ZPE drive that uses toroidal plasma, and then you have designs for stationary portals. All 3 of them, from different angles, converge on the exact same underlying physics. You have to create a macroscopic time crystal. And when you see multiple, separate paths all leading to the same summit, that's a pretty darn good sign that the summit is real.
Which, of course, brings us to the billion-dollar question. Maybe the trillion-dollar question. We know for a fact this works at the teeny-tiny nanometer scale inside a quantum chip. But does it scale? Can we go from sending a single qubit of information to maybe one day transporting an actual person?
And look, there are really strong arguments on both sides of this. On the yes, it can scale side, the laws of physics that govern this stuff don't really care about size. And we have precedents, right? Lasers are a perfect example of a quantum effect that scales up beautifully. But the challenges are huge. Decoherence, that's the enemy. It's when the quantum system just falls apart by interacting with the outside world. It gets way, way worse as things get bigger. The energy needs could just explode. And here's the real kicker. While other quantum things have scaled, there is absolutely zero precedent for scaling a time crystal this big.
So, what are the odds? What are we really talking about here? Well, based on the current theoretical models, before a single piece of hardware is built, the estimated probability of success is somewhere between 15 and 30%. Yeah, it's a long shot, for sure, but it's not zero. And you have to weigh that against a potential reward that is, and I'm not exaggerating, civilization changing.
And the good news is, this isn't just wishful thinking. There's a plan, a clear, logical, step-by-step scientific roadmap to figure out if this is for real. You start small. Step 1, test the most critical individual parts for a few $1,000,000. If that works, you move to step 2. Build a small 30-centimeter prototype to see if the scaling principles even hold up. And only if both of those steps are successful do you even think about committing to the full-scale build. The point is, we can know if this is viable long before spending the really big money. And so, this is where we'll leave it. This whole journey, from a solid quantum fact to this wild potential cosmic future, it leaves us with a really profound question, doesn't it? I mean, we all think of time as something that just flows, right? One direction, unstoppable. But if it can be structured, if time itself can form a crystal, what does that actually mean for our past, our present, and our future? For our whole understanding of reality? The answers, well, they're waiting for us in the experiments that are yet to come.